I'm excited, Dawn. This is going to be fun.
Yes, this will be lots of fun.
All right. I think we are live. So welcome everyone to Live from NCCE. I'm your moderator, Tammy Dunbar. Happy and thrilled to be here with my good friend, Don Carney. Don and I met at E2 in Seattle back in 2015, so I've known him a long time. He's the CEO and founder of Fluidity, but he's got a great thing to show you today. It is MathWhiteboard, and it is, I say, it is the teacher's favorite F word, free. So, Don, thank you for joining us today, and tell us all about MathWhiteboard, the wonders of MathWhiteboard.
Well, Tammy, thank you very, very much for inviting me. It's a pleasure to be here and a pleasure to have this opportunity to chat with folks and to give you a tour of MathWhiteboard. Again, my name is Don Carney, and today I'm going to be showing you MathWhiteboard. This is, we believe, the first collaborative whiteboard designed specifically for mathematics teaching and learning. And I'm going to jump right ahead into MathWhiteboard and show you what it's all about. So let's jump in really quickly here. I'm going to open up a MathWhiteboard. By the way, I happen to have two browser windows open here on my screen, you'll notice. And that's because I'm going to be showing you at some point the interaction, the synchronous interactions, the real-time interactions that a teacher and a student might be able to have. Because one of the reasons we built MathWhiteboard was that we wanted to provide a tool, an online tool for math teachers to communicate synchronously with their students. And by the way, I should mention at the very beginning here that MathWhiteboard is a free tool that's available for anyone to use. It's just a website. We wanted to make something that was free and also barrier-free. So it doesn't have any accounts or subscriptions or logins or passwords. It's just a website that you go and start using. So let me jump in and show you what MathWhiteboard is all about. So I'm going to start a MathWhiteboard here. And by the way, I happen to be using a Windows tablet here, and I'll be writing on the screen with my stylus and my finger often, and you'll see that. But keep in mind that MathWhiteboard is a website, mathwhiteboard.com. And you can go and use it within any browser and on any type of device. So I happen to be using a Windows tablet. This also works on Macintosh computers or iPads, MacBooks, Chromebooks, any device. And we also have a keyboard-based interface. As I said, you'll be seeing me writing a lot on the screen with my stylus, but everything I do with a stylus can also be done with a keyboard and a mouse. And I'll show you that as well. So let me jump in and show you what MathWhiteboard is all about. So I'm going to turn off if my cam is not already turned off, I'm going to turn off the webcam because my face is going to get close to the screen as I write on the screen. So think of MathWhiteboard as like a smart piece of math paper. For example, I can write some math. 1 plus 2. That's pretty simple math, but you'll see it recognizes what I write, and I can get an answer. 1 plus 2 is 3. I can change the math. I can change the 1 by scribbling it out and write in another number. 2 plus 2 is 4. I can change that 2 to an A, and then I can assign a value to A. So when A is equal to 1, A plus 2 is equal to 3. I can change the value assigned to A to a 2, and the answer, A plus 2, updates dynamically. I can change the value assigned to, I can change the 2 to a B, and then I can assign a value to B. A plus B, when A is equal to 2 and B is equal to 3, is 5. I can write more math on the page, maybe A minus B, or A times B, or maybe A over B. And I can get an answer for all of those expressions. Now, underneath the hood is a very powerful computer algebra system. So far, you've seen me do some simple numeric arithmetic and algebraic arithmetic, but we can also do some more advanced mathematics. So here, for example, is a definite integral. Right? And we can get a solution for this as well. Now, when I go back and I change the value assigned to A from a 2 to a 6, all of the answers on the page update dynamically. Or if I change the value assigned to B to a 4, you can see again all the answers on the page updating dynamically. I can even assign to A an expression like x plus 1, and now x plus 1 substitutes for A across the page. So learning math is about seeing connections between things. Here, we're looking at the relationship between A and B with respect to some operators, plus, minus, divide, and so forth. In algebra-oriented topics, we look to see connections between other types of things, like algebraic expressions and graphs and tables and so forth. So here's a math expression that we're all familiar with. Y equals mx plus b. That's the slope-intercept form of a line equation. So I've written y equals mx plus b on the page, and it has recognized what I've written. And with a simple gesture, a stroke of my pen, I can get a graph. I'll do that again. So with just a stroke of my pen, a swoop, we can look at a graph. Now, you'll notice that we can pinch and zoom the graph with our fingers, and that we've selected default values of 1 for m and b. But I can change that. I can make m equal to a different value, like 2. And the graph updates dynamically. Or I can change the value assigned to m to be a different value, like a 3. And all of a sudden the graph updates. I can also create a slider for m, and now show very dynamically and interactively what m, or slope, really represents. What's slope? That slope. When slope is negative, it looks like this. When slope is positive, it looks like that. B is the y-intercept. And I'm going to create a slider for b. The way we create a slider in MathWhiteboard is we draw a straight line down from the equal sign of an assignment. An assignment is like we see here, b equals 1, or a variable equals a number. So I just draw a straight line down, and now we can see b changing. But wait a second, what really is b? Let's plot this point, 0, comma b. Right now, when we plot that, we can really see what b, the y-intercept, really represents. What's b? Well, it's that point where the red line passes through the y-axis. There's something I say often that I think is really important. Learning math is about seeing connections between things. Here, we're looking at the relationship between an algebraic expression and a graph. You know, often in the math classroom, the math teacher, the math student, the mathematician uses a primary workspace, paper and pencil. That's where they do, that's their primary workspace, and that's where a lot of work is done. But we use these complementary workspaces as well, like a graphing calculator or a computer, to look at a graph or a solution or a diagram or an animation. All of a sudden, we've got these multiple workspaces, and they're all disconnected. And it's difficult to see the relationships between representations that are in different workspaces, because these workspaces are disconnected from each other. How do you see the relationship between what you've written on paper with a pencil and what you see on the screen of a graphing calculator that you typed in to get, to show a graph with a keyboard? So not only are these workspaces disconnected, they're also far from each other physically, but also cognitively. So what we're trying to do with MathWhiteboard is bring together into one workspace all of these mathematical representations and allow the user to move fluidly between those representations and hide behind the scenes all the technical stuff. Let me show you another example that really demonstrates this in a very powerful way. This is a related rates problem. So I'm going to draw 2 cars. Yep, those are cars. I'm not an artist. We'll say this is car A, and this is car B, and we'll give length to the road. Say the road has 1,000 units in length. Then we'll write a couple of math expressions here describing constant velocity for car A. We'll say that car A is going 80 miles an hour. That's a linear function. So it's the location of car A along the x-axis is defined by 80 units of distance per unit time. Car A is going 80 miles an hour. Car B is a police car that has to accelerate to catch car A. We use a quadratic to describe constant acceleration. Now, in MathWhiteboard, we have this ability to connect handwritten mathematics with hand-drawn sketches. It's called math sketching. Under the More menu, I can turn on math sketching. And when I turn on math sketching, we get this little slider that pops up. And on the right-hand side of the slider, we can see these player controls. When I click the play button, we can see the cars moving across the screen in an animated simulation as described by the math. Pretty cool. Pretty cool for us, and we're adults. Imagine what happens when you show this to kids in the classroom. Their heads explode. They start asking really great math questions that require knowing more math. Like, can you make the car go faster? Can you make it bump up and down? They're engaged and asking really great questions. Now, from a high-level perspective, what we've just done, from a pedagogical perspective, we've connected this very abstract algebraic notation on the left, the very concrete example on the right. Oftentimes when we're learning mathematics, we need to conceptualize. We need to understand, why does the math matter? How can I use it in my normal life? For kids, driving a car, that's something they may do in their normal life. And understanding that the algebraic notation can be used to model things that we do in our normal lives is really important. And it demonstrates from the student's perspective why it's important. So now that's a high-level pedagogical perspective, but this is a very practical example we see on the page here. This is a related rates problem, and from, again, this practical perspective, related rates problems show up on standardized exams all the time. In algebra, this type of related rates problem would be combined with a couple of questions, like, at what point in time does something happen? Or at what point in distance does something happen? Here the question is, when does car B overtake car A? And we can see in the simulation, well, it happens just about there. That's an observation, not a math answer. We want to get to the math answer. How do we do that? Well, there's a couple of different ways. Let me show you one of them. What I like to do is I like to explore. So let's graph these functions. And I'm just swooping through both of those math expressions. And we'll take a look at the functions as they're plotted in the graph area. And we can see that there are a couple of points of intersection, and those points of intersection are usually things that are interesting. So we can see one is at the origin and one over here in the quadrant. The one in the quadrant is what we're interested in, because at the origin, that's where the cars are starting. Over here in the quadrant, we can see that's when the quadratic overtakes the linear, or when car B, the accelerating car, overtakes the speeding car. So we can see that happens at, if we look at the graph, at about 8 units of time and at about 650 units of distance. So that's our hypothesis. When time equals 8, the car should be at about the same spot. So let's test the hypothesis by running the simulation again. So I'm just going to bring the timer bar over here, and I'm going to move the slider for t over to 8. We'll see if the cars are at the same spot. We know we're on the right track. They look like they are, but we haven't proven anything yet. We're just eyeballing the graph or eyeballing the simulation. It could be 8.01 seconds, or it could be 7.9 seconds. Let's prove it. The way we can prove things in algebra is through substitution. So let's substitute in the value of our hypothesis when time equals 8 to see if the location of car A along the x-axis is what we think it might be from the graph, about 650. Let's see. 640, pretty close. If B sub x is also 640, then we have proven the hypothesis. Pretty cool. So I love this example because it demonstrates the power of having multiple representations in one workspace and having everything connected. We've got algebraic expressions, we've got a solution, we've got an animation, we've got a graph. We could look at a table of values, and everything is connected. So when the student said, make the car go faster, well, we can change the 80 miles an hour to 90 miles an hour. And look, all of a sudden, the graph changes. The point of intersection moved. The solutions changed as well. If I ran the simulation again, the accelerating car wouldn't quite catch up as fast to the car with constant velocity. So let me pause for just a moment and ask Tammy if there are any questions. Otherwise, I'll continue.
Minds are just blown right now, Don.
Oh, cool.
What? That's incredible. It's so interactive. And to see the relationships as you change the numbers is just, we can see all of the applications. The one thing that I think people are curious about is this is great for high school math. Are there any applications for, I teach 5th grade, for like elementary?
That's a great question. And it's a great lead in to the next thing I'd like to show you.
Okay, great.
So, keeping with this idea of seeing relationships between things, I'm going to show you another bit of functionality that is pretty unique to MathWhiteboard. We have this ability in MathWhiteboard to show relationships between all sorts of things, including numbers and algebraic expressions. We have this ability to color code equivalences on a page. And let me show you what I mean by that. So under the More menu, I can turn on Highlight Equivalence. And now anything I write on the page or type on the page will be tested for and color-coded with a color that is equivalent to anything else on the page that's equivalent as well. Let me show you what I mean. So we know the number 3 and the number 2 these are not equivalent to each other. So they're color-coded differently. And the number 4 is not equivalent to 2. So again, it's color-coded differently. But the number 6/3 is equivalent to 2. And the number 4/2 is equivalent to 2. So we color code them the same. Of course, this is very applicable when we're possibly looking at equivalent fractions and decimals and so forth. So for example, we could turn off the highlight equivalence and put some other fractions on the page. Maybe we have the number 5 and the number 10/1. And maybe we have the number, let's make that 10/2. So it's equivalent to 5. And then we'll have the number 20/4. And we might want to play a little matching game here, right? So maybe, 20/4 and 4/2, those kind of look similar. And maybe 10/2 is 5. And then maybe we have this, maybe we'll put this down here with these guys. Now, when I turn on my highlight equivalence, we can see all of a sudden, wait a second, did we make a mistake? Well, if we were grouping by equivalences, of course, we made a little bit of a mistake here. This 2 should have been up here, and this 4/2 over there, and then the 20/4 over here. Of course, this is testing for equivalences of numbers. We could also test for equivalences within algebraic expressions. So, for example, we know some identities. So A plus B and B plus A are equivalent. So they're color-coded the same. And A minus B and B minus A are not equivalent, so they're color-coded differently. Now here's something for more advanced levels of mathematics, possibly Algebra 2 or pre-calc or calculus. We have trigonometric identities. So tangent of theta is not equivalent to sine of theta, right? But it is equivalent to sine of theta over cosine of theta. So now all of a sudden, these two will be color-coded the same. Pretty cool for identities and pretty cool for numbers, but possibly the most powerful way in which to use this color coding is in step-by-step problems. And let me show you what I mean. We'll start with an algebraic example. So for example, we'll have 2x plus 3y equal to 4. If we wanted to solve for x here, now of course, we all know as math teachers that and mathematicians, we know that every step in a step-by-step problem should be algebraically equivalent to any prior step or any subsequent step. So if we were to solve for x here, what would we do? The first thing we might do is move the plus 3y over to the other side. So let's do that. So the first step here might be 2x equals 4, and we're moving plus 3y over, right? So that must mean that it's plus 3y over on this other side, right? Hey, wait a second. It didn't change colors to that original statement there. I must have done something wrong. Oh man, what did I do? Well, I forgot to change the sign when I moved the plus 3y over. Let's change the sign to a negative. Okay, I changed the sign. Now, all of a sudden, that first step is color-coded the same as the original statement. So I know that my first step there is equivalent to the original statement. So we haven't really given you the answer. We've just given you that immediate feedback and the visual cue that you made a mistake. Now we can continue on, and we can solve for x and write in our answer. And of course, one of the things you'll notice when you start using fluid math is that, and this is something I do all the time, I always look at what was recognized. And you can see here what was recognized. I didn't like my 4, so I'm just going to rewrite the 4. Yeah, that probably should be better there. Oh, and then I can just drag this over, and now all of a sudden we've got the correct expression. And now I know that the final step there, my answer, is the correct answer because it's color-coded the same as every other step. Pretty powerful use of a visual here to inform the student that they've made a mistake and give immediate feedback. Of course, when you're a student and you're solving step-by-step problems, sometimes you face these problems that are 6, 7, 8, 9 steps long, and it can be very disheartening and discouraging to get to the bottom, get to the last step and realize you got the answer wrong. And you have to go back and figure out where you made the mistake. And if you made the mistake early on, oh man, you got to do the whole thing over again, which is a bit of a bummer and again, discouraging and disheartening. Let me show you how this could also be used at the lower grade levels in an example where maybe we're looking at order of operations. So let's take a look at another example. So 2 minus 3 times 2 minus 3. Let's say we have to solve this. The first thing we might do is we might multiply the 3 across the parentheses here, right? So the first step might be 2 minus, so it's 3 times 2, so this must be 6, and then minus 3 and minus 3, that's got to be minus 9, right? Oh, wait a second, it's not the same color as the first step. That means I must have done something wrong. Oh, you know what? I forgot to multiply. It's minus times a minus, that's a plus, right? Okay, oh, it's the same color, cool. So I have gotten, I've gotten the first step correct. Now I can go on to the next step. So it's now the next step is 2 minus 6, or I'm sorry, 2 minus 6 plus 9. So that's got to be 15, right? So it's 2 minus 15, right? Wait a second. Oh, it's not the same color. I must have done something wrong again. Oh, it's minus 6 plus 9. Oh, that should be 2 plus 3, right? Okay, now I know what 2 plus 3 is. That's 5. So again, 5, that's color coded the same. So now I've gotten to the bottom and I know I got the answer right. But of course, you know, in math, there's always multiple ways to solve a problem. So this is one way to solve a problem here. Another way to solve this problem might be this solution. So 2 minus 3 times 2 minus 3, that's a minus 1 here, right? So that's the first step. And then the next step might be, so it's 2 minus 3 times minus 1, that's got to be minus 3, right? Oh, wait a second, what did I do wrong? Oh, I forgot to multiply the negative times a negative, that's a positive, right? So, and then I know what 2 plus 3 is, that's 5. So pretty powerful, I think, a bit of functionality here that can be used across a wide swath of math topics because we're always solving step-by-step problems. Let me just pause for another second here and see if there are any other questions that you might have.
We've got people on Facebook who are tagging other people going, you've got to see this tool.
Oh,
this is
awesome.
So perfect. But I do have a question because I can see students using this and following the color coding. My question is this an individual website or can you share a link so you can collaborate?
Man, that is a great question. And again, leads right into the next thing I'd like to share with you.
I swear we didn't plan this.
So I'm going to just start a new math whiteboard here. I just click on new whiteboard there, and I get a new whiteboard on my page here. And every math whiteboard has a unique URL. So up here, I've got this unique URL. And I can get a copy of that URL by clicking copy link. And that now that I've copied that URL, I can paste that into my learning management system. Maybe it's Microsoft Teams, or maybe it's Google Classroom, or maybe it's just a course web page, or maybe it's an email to a student. And what I'm going to do here is I'm just going to paste that URL right into the browser on the left-hand side here. So what we've got here is we've got two browsers on the screen here. The browser on the right represents one user, maybe the teacher on her computer at home or in the classroom. And the browser on the left might represent the student on his computer, maybe at home, maybe in the classroom also. But these two browsers represent two different users on two different computers. So when the teacher on the right-hand side writes something, so for example, maybe the teacher writes a math expression like y equals x, right? It shows up on the screen for the student on the left. But this is a shared collaborative page, which means that this is it's a real-time collaborative whiteboard designed for math. So I wrote that originally on the right. I'm going to edit it on the left. So maybe the teacher says, change that math expression to slope-intercept form. So now the student on the left edits it and changes it. Now, of course, you have all the tools that you have available to you within Math Whiteboard are also available when you have this collaborative space. So, for example, we can create. Whoops, I want that to be. And you know what I'm going to do? I'm going to turn off the color coding here because we don't need it. So I can create sliders, and we've got graphs on the page and everything. So this is a shared collaborative page that teachers can share with their students for collaborative problem solving and so forth. So yes, the answer to the question is yes, it can be shared that way. Now, teachers are very clever This is a bit of functionality that is available in MathWhiteboard, and we didn't really intend it to be used this way, but teachers are using it this way. It's really cool. So MathWhiteboards can have multiple pages, and I can add a page by just clicking on the plus key up here, or I can copy any of these pages. So I can hit Control-C, and then I can copy that page. And what the teachers have been doing is they have been assigning groups of students to each of these pages. So, for example, maybe group 2 is on page 2, and maybe on slide 3 we have group 3, and then maybe on slide 4 we have group 4. Right now, let's say the student on the left-hand side is in group 3 here. So maybe the student over here turns on. This is Johnny and Mary working together. So maybe they write a little bit more math on the page, and maybe they, maybe they're doodling on the page as well. So the teacher on the right-hand side can, see what's happening in real time as the students are modifying their pages. So, for example, she can watch each of the groups of students working on their respective pages, which is a pretty cool bit of functionality. We were really surprised to see teachers doing this. So I'm going to continue on and show you a little bit more of the functionality available here in MathWhiteboard. And I'm going to do that on the right-hand side here. I'm going to open up a new whiteboard. And, oops, let's create a new whiteboard here. So one of the bits of functionality that teachers really love about MathWhiteboard is that, especially math teachers who have folders full of worksheets in PDF form. Here's an example of just a math worksheet, an algebra worksheet, solving systems of equations. I'm going to open this worksheet here just in PDF Acrobat Reader. You can see the PDF file. But I can take any PDF file and drag and drop it right into the MathWhiteboard space, and all of a sudden that PDF file becomes the background for my MathWhiteboard, upon which I can do all of my cool MathWhiteboard stuff. Whoops, I just dismissed the page by mistake. Let me open that up again. Sorry. So I'm just going to expand the page here. And now we've imported this PDF file. I can do all of my cool MathWhiteboard stuff, like write math on the page.
Screen sharing. I think you need to share your screen again.
Oh, I'm sorry.
It's okay. We see your smiling face. Although we've got people now in the audience saying, "I wish I were a math teacher so I could use this. This is amazing." So.
Oh, okay. Sorry, I dropped the page there.
No, it's fine. It's fine. So I just think that's so valuable to be able to put a PDF right into it like that. I'm still just going, because that's been a real problem.
Cool. Yeah, one of the challenges that teachers face, especially during the pandemic, is working in real time. So when teachers all of a sudden went from years or decades teaching in the classroom synchronously in a synchronous classroom environment where you're working one-on-one, one on a group, and you're working in real time with your students, all of a sudden now you're in this online environment where a lot of the communication is asynchronous. And any of the synchronous communications you have as a math teacher are kind of awkward, because now, math is a subject area where you have to see it and hear it at the same time. It has to be shown to you while it's being explained to you. I cannot just explain math to you, and I cannot just show you math. I have to do both at the same time. And that's usually, it requires a synchronous environment. And the tools for synchronous communication of mathematics that are available, just there aren't any. They don't exist. So this is a tool that provides for that. So I think it's a pretty useful tool. So again, back to the background being a PDF file. We can do all of our math on here. We can get solutions. We can annotate these pages with answers and so forth. And by the way, this was a multi-page PDF file. I can just when I drag and drop it in there. And by the way, all of a sudden what happened was that a static PDF file that we printed out on paper and handed out to the kids becomes a live, interactive, dynamic page, a web page that can be shared synchronously with our students. And by the way, in its simplest form, this MathWhiteboard could just be used as an annotation tool for PDF files. This does not have to be a math worksheet. It could have been a chemistry worksheet or a history worksheet. And you can just go and use the annotation tools. We happen to layer on top of it all these fantastic mathematics tools which make it a really powerful environment for teaching and learning mathematics as well. So I want to be cognizant of time. There's still a few more things I could share, but let me know if you could let me know if I'm bumped up against the end.
It is 4:30, so we are at the end of our time. But my jaw has still dropped, and I'm sitting here thinking I need to do asynchronous teaching as well. And I'm looking at this though and thinking if I were screen recording as I were working on MathWhiteboard, then I would have the whole lesson. I could show them the relationships and even make an instruction video, right? To show them, here's how you use MathWhiteboard. Now go do your math.
Absolutely.
And it's free, Dawn. It's free.
It's a totally free system. We wanted to build something that was, as I mentioned earlier, barrier free. There's no logins, there's no passwords, there's no subscriptions. It's just a website, and you can go use. And the thing that I've been asking folks is that if you think it's cool and you like it, please spread the word and let other folks know about it.
We do have one other question, and Maureen is asking, how do kids turn these in once they've annotated them? Do they send the link to the teacher?
That's a great question. Now, one of the compromises we face with building a system that's barrier-free, meaning there are no accounts and no passwords, is that the documents don't necessarily associate with an account. There's a couple of things you could do. You could, if this were your own private document and you didn't share it with anyone, you could take the URL and give it to your teacher. Another option is to go to the print menu within your browser. Oops, that's print here, and you can print to PDF any of these MathWhiteboard pages. So I could save this as PDF and then hand that in.
Yeah, that would make it really easy if you print to a PDF to attach it to a Google Classroom or a Teams assignment and turn it back in. So yeah, that's just amazing. Everyone is enthusiastic about this, Dawn. I so appreciate you taking the time to come and show us MathWhiteboard. We are thrilled. And of course, this is recorded, so this will be on our YouTube and Facebook pages, so anyone can come and rewatch this over and over again to have their minds blown. Thank you, Dawn, for taking time out of your day to share it with us. And Dawn, we've got another guest coming next week. I think you have a slide for that person.
I do have a slide. Just one last comment here. If you'd like to reach out, please go to mathwhiteboard.com, and you could also reach us on Twitter at MathWhiteboard. Feel free to reach out. I'm always happy to give demos to folks. So if you're working in an organization where you think other people would like to see what I just did, I'm happy to have a demo call with anyone at any time. So just reach out, and we'll get in touch and schedule something. So let me pop up the next slide here. This is for next.
Yes, so next week we have Darren Clay, who was a featured speaker at NCCE 2021. Darren's amazing. He is going to be talking all the way live with PowerPoint next week. He's got some great stuff to share with us, just like Donald had today. So Donald, thank you so much for being here today. Everyone, thank you for joining us. Hello, Mohammed. And we'll see everybody next week back here, 4 p.m. Pacific, 7 p.m. Eastern, live from NCCE. Have a great evening, everyone.